to take a look at an extension of multiplying binomials, and one of the special cases is something called a perfect square, where you actually have one binomial but you're squaring it. And first, the only difference between multiplying a perfect square and multiplying two binomials is that you have to write the perfect square out as two binomials. The FOIL pattern still applies. So in this first example where we have 3x plus 4 all squared, remember, anytime you square something, it means you're multiplying it by itself, right? So, for example, 5 squared is the same as 5 times 5. In this instance, we're going to do 3x plus 4 times 3x plus 4. So 3x plus 4 times 3x plus 4. Okay. So those two things are equivalent. They mean the same thing. So 3x plus 4 all squared is the same as writing out two binomials of 3x plus 4 times 3x plus 4. So now that we've gone through and we've expanded that out into two binomials, we're going to use our FOIL pattern. So we're going to multiply our firsts, then our outsides, our inside terms, and then our last terms. So this is going to give us 3x times 3x. So that's going to be 9x squared. 3 times 3 is 9. X times x is x squared. We're going to multiply 3x times positive 4. That's going to be positive 12x. Then we're going to multiply the inside terms of positive 4 and 3x, and that gives us also 12x. And then finally, we're going to multiply positive 4 times positive 4, which gives us positive 16. So then we're going to collect our like terms, and we end up with 9x squared plus 24x plus 16. If we do it again over here in the middle, again, we're going to have to first write this out as two binomials. So 4x minus 5 times 4x minus 5. That's going to be equal to, again, we multiply the first terms together, so 4x times 4x. So that gives us 16x squared. 4 times 4 is 16. X times x is x squared. Then we multiply 4x times negative 5, and that gives us negative 20x. Then we multiply the inside terms of negative 5 and 4x, so that's also another negative 20x. And then finally we multiply the last term, so negative 5 times negative 5, which is positive 25. Positive 25. So now we're going to collect our like terms, and we end up with 16x squared minus 40x plus 25. Okay. So we can do this as well just with straight algebra. You don't even need numbers in there. So just by way of example, if I did this last example here on the right, it would be a plus b times a plus b. And again, multiplying the firsts, you get a squared. So a times a is a squared. A times b is plus ab. B times a is the same as plus ab. And then b times b is the same as b squared. So if we collect our like terms, we end up with a squared plus 2ab plus b squared. Okay?